Right, so this will be integration by parts continued. So this is starting with the tabular method. So this is a way that we can help out if we have something that is going to have where you're going to have to keep doing integration by parts over and over and over again. Okay, so we're going to look at a couple of examples of when you could use this. So basically, you're going to fill in a table where you're going to put in this part is going to be U, and this part is actually your DV. Okay, and so you're going to make a column and then you're going to answer the question. So we'll look at how we would do that for x cubed e to the 2x. Because we've done an example with x squared and we saw that we had to do it twice, integration by parts, and then one more integral. Well, now it would be 3 times. So the way you set it up is you just make the first column will be u. So in this case, I'm going to pick u to equal the x cubed. So it needs to be something that is eventually going to go away. Otherwise, this method really isn't, I wouldn't use it. I think students get too confused. So if you're not going to have one of them go away eventually, don't use the table method. So that means dv must be the part that's left, okay, including the dx, but we don't need to write it here. And then your third column, you're going to write plus or minus, and you start with +1, and then you just alternate, okay? So then I'm just going to go ahead and I'm going to take all my derivatives. So I'm just going to take the derivative each time. So this is 3x squared, then this will be 6x, then it will be 6, and then it will be 0. Once that derivative comes down to 0, I know I have the last thing I need to do. So now I'm going to integrate on the right. So when I integrate e to the 2x, remember that you always get the exponential back, derivative times 2, so therefore integrate divided by 2. So I'm going to write it as times a half for space. Then I would just keep doing that. So you're going to keep getting the exponential again, and you're going to keep multiplying by a half until you end up on this last column. And the reason, again, we know it's the last part is because I did all the derivatives first. Okay? Then that means the answer to the integral, okay, the integral of x cubed e to the 2x dx, in fact, equals. So what you're going to do is you're going to follow the gray arrows. So I'm going to do, let me use a different color to go across that so you can kind of see. So I'm going to do this, and then this, and then this, and then this, just like it says. So x cubed times 1/2 e to the 2x. So that's going to be 1/2 x cubed e to the 2x. And then I'm going to use the sign that's right here, which is plus. Oh. Yeah, this is kind of not written right. So we should use the sign that's there. So I think that we need to, if we're going to use the table this way, then we have to actually start with -1 if we're going to use it this way. So that's a different way than I normally do it. That's just how it's already written. Because I usually do this and go straight across. Then it would work. But since we're going to have a line drawn like that, if you're going to go diagonal, then start with -1. So then it would be minus, because minus is what the arrow is pointing to. Then I do the next product, which is 3x squared times 1/4 e to the 2x. And then I'm going to use this, which is plus. So that's going to be, you have 1/4 times 3, so 3/4 x squared e to the 2x. And then you'll have plus, and then you'll have 6x times 1/8 e to the 2x. So 6/8 is 3/4 x e to the 2x. Minus, because that's the next sign, and then 6/16, which would be 3/8 e to the 2x plus c. Don't forget your plus c, always there at the end. Okay, so if we're going to do the table written this way, then we're going to start with -1, In order to do that, there's different ways to do it, but if we want to use the table this way, then we're going to go ahead and have to do it like that. Otherwise, you just remember that the first one's positive and the next one's negative, and so on. Okay, so if we use the table method to integrate this, so I'm going to actually add a column for the plus minuses, and so we're just going to do it that way. So we're going to put plus minus here, and we're going to start with minus for the first, then plus, because actually we're pointing at the plus, okay? So this is u, and this is dv, okay? So u is going to be x squared, dv is going to be sine 4x. Then I'm going to take derivatives. So I'm going to get 2x, then I'm going to get 2, then I'm going to get 0. So I'm going to have 4 rows here. So I just do sine x, sine of 4x, I'll have to integrate 4 times. So I integrate that. If I integrate sine of 4x, I get negative of cosine of 4x, and then again, normally it would be times 4, so that means divided by 4 in this case. And then I do it again, so the integral of cosine is going to be sine with no SIGN change. But again, because of the 4 that's on the inside, I'm going to have to do divide by 4, which makes it a negative 1/16. And then when I integrate again, this time I get negative cosine, so that's going to be positive, and I still get the 4x inside, but then again I have to divide again by 4 because of the inside of that. And then just alternate these, and if you do that, then all you have to do to get your answer is just write this minus this plus that, and then you're done. So my answer would be that integral equals, it would be negative 1/4 x squared cosine 4x minus 2x times negative 1/16, so that's going to end up making it plus again, and then 2/16 would be 1/8 x sine 4x, and then plus 2 times 1/64, which would be 1/32 cosine 4x, and then don't forget, always, always, always plus c. Okay? So that's what you do for the table. Now, for this problem, you would not use a table. You could try to use a table, but I don't like that because I think students get really confused that way. So here's why I wouldn't use a table for it. Neither one of these functions is ever going to go away. They're both going to keep having new functions that'll be there. So here's how we're going to write this problem. So I'm going to actually change my page width here because I'm going to actually need this to be written out. So that makes that type really big, but I won't write that big. All right, so I'm going to integrate e to the x cosine x dx. Okay, so I look at it and realize, okay, it's not a formula. It's not u substitution because one of these isn't the derivative of the other. It is a product. So I'm going to try integration by parts. So I'm going to let u equal, and it doesn't make any difference either one because neither of them is going to get easier. And dv then will be cosine x dx. And it doesn't matter, but if you have to integrate by parts again in the answer integral, then you just need to be sure that u continues to be the exponential and dv continues to be the trig function. So my derivative is going to be e to the x dx. And if I integrate cosine x, I get sine x. Okay, so then I'm going to come over here. Now I'm purposely going to write it to the right and not underneath, and you're going to see why in a minute. So I'm going to get uv, which is e to the x sine x minus the integral of v du, which is going to be e to the x sine x dx. So now I have to do that integral. Well, that integral is also going to need integration by parts. Now I just leave u and v. I don't make them u1 and u2, but you can do that if you want. I just realized that once I've done the first substitution, I'm finished with it. So I don't need it anymore. So in order to do this integral that we have left here, I need to let u be the same type of function and dv the same type of function, okay? So u is going to be e to the x and dv is going to be sine x dx. So therefore v is minus cosine x and du equals e to the x dx, okay? So I'm going to write this down because it's already done, and then I'm going to do minus bracket because I want to be careful, because remember, integration by parts has a couple of terms. So I need uv, which is minus e to the x cosine x, minus the integral of v du, which is going to be negative cosine x times e to the x, so that makes that plus e to the x cosine x dx. Now, before I do anything, I'm going to I'm going to distribute. So minus a negative becomes plus e to the x cosine x, and then I distribute the minus. I'll have minus e to the x, or integral e to the x cosine x dx. Now, in your mind, you might think, okay, well then we're going to have to just do u substitution again. But here's what I'm going to notice. Instead of doing that, I'm going to notice that my thing I'm trying to solve for, okay, what I'm trying to solve for is this. Okay, so when I'm done, I want it to say this integral equals something. Well, on the right-hand side, I just ended up with the same integral. So basically, they're like terms. So if I want to solve for that expression, just like normal, regular old solving, I'm going to add that to both sides in order to get it on the other side. So that means on the left, I now have two integrals of e to the x cosine x dx. And on the right, I have e to the x sine x plus e to the x cosine x. And then you can go ahead and put plus c. And then I'm almost finished. I just need to remember that I need to finish because I'm trying to find what's highlighted, integral e to the x cosine dx, but I have two of those. So I need to divide both sides by 2 or multiply by a half. So every term just gets multiplied by a half. And now I have my answer, because again, the answer is, and then don't forget the c can just stay a c. You can put c1 if you want, but half a constant, still a constant. So the goal was to have this expression equal to something, and that's what I got. Okay, and there's nothing left to integrate. Now, I would triple, quadruple, definitely mark this example. I would highlight it. I would make myself a bunch of notes. We're actually not going to do the last example, so you could just sort of cross off that example 12, and then you could put in some notes for yourself about how important this problem is, okay? Because this is one that will sneak up on you if you're not careful and you don't practice. So basically, I'm still using integration by parts, but what's going to happen is, because both of those functions continue to keep coming back, like they don't go away, if I'm lucky, I end up with the term I'm solving for on the right, and then I can move it over. Okay, so I would definitely highlight that. The other ones are a little more straightforward. They just kind of work the way they work. Okay, so make some notes to yourself and keep track of that. And that's the end of this lesson.